Alright, this is Geometry Notes section 4.5, which is notes number 26. Prove triangles congruent by angle side angle and angle side. Put your name, date, and class period. Here's your essential question. For one side of one triangle is congruent to a side to another angle, what information about the angles would allow you to prove the triangles are congruent? The answer is to have angle side angle and have an angle then a side. Here's your postulate that needs to go into your foldable, which I'll show you in class because I don't have it with me right now. But it says angle A would be its corresponding angle, which would be angle D. That AC here would be DF. And then angle C is the double arcs, which would be corresponding to angle F on the other side, which makes triangle ABC congruent to triangle DEF. Realize this side is between the two angles. It must lie between them. It cannot lie outside. On the theorem one, it has angle side. For this one, the two angles are in line and the side is on the outside of it. So A is still congruent to D, C is still congruent to F, and then BC, which is the side not between the angles but around the edge of it, would be congruent to EF. That means triangle ABC is congruent to triangle DEF. Realize it could be either side. It could be AB is congruent to DE or BC congruent to EF. Just needs one of those sides to be congruent. Example 1 says, can we prove that triangles are congruent based on the diagram given? If so, I'll give you the postulate of the theorem that you're using. If you're looking at these pictures, this involves all of the angles that we've had before, or all of the postulates and theorems to try to prove triangles congruent. If I look at the first one, I have alternate angles here are congruent. I also know that there's an angle in the center called vertical angles, but I do not have angle available to me. I do not have any right angles, and I don't know anything about the sides, so there's not enough info for this first one. Not enough info at all. If I look at the second one, I have double arcs at the top, single arcs on opposite corners, which means this is flipped with an angle at the bottom, and I say yes, this is possible because this would be angle side. And the next one, I see I have alternate angles, I have a side, and then I have vertical angles right here in the center, so this would be a yes by angle side angle. On the back side of your paper, we have some proofs, but these are called flow proofs, so like flow charts. This is a flow proof. Looks a little bit different than the others. It says in the diagram, which I don't have the diagram available, so hang on a second. Alright, on the back of your notes, you don't have this picture on your notes. You need to copy it down while I fill in the gaps here, because this is a flow proof. It's different than a two-column proof. This is just a flow proof to show you how to do those if you like that better. Okay, the end box of a flow proof is what you have to prove, so you always put that in the end box. And then right below it you say the reasons for these. So it's like I have my givens up here. I'm going to put the parallel one here because I know that the parallel you have to get something from it and then to here. And then the G is congruent to angle B is a direct line to this because that's part of my triangle that I need to know, because I have, okay, sorry about the dog. That's the angle, and then the parallel sides, that means I have parallel sides cut by transversal cutting through it. That means that this angle here and this angle here are congruent to each other, and that's what I'm going to put in this blank here. The angle A is congruent to angle C, and the reason is that these are alternate interior angles. And oh, I didn't put it over here, but these are the given, so I have to write it right below it so that I know that's the reason for those particular items, is that these two are given. These are ultra interior angles, and that's actually a theorem. And then that gives me an angle, and there's an angle, and I need either, for my options that I had so far, is I had side, 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 angle, side, angle, and angle, angle, side. But then I also have hypotenuse leg, hypotenuse leg, angle, or LL. But I don't have any right triangle, so I'm not even dealing with this column at all. I'm dealing with the first column. I have two angles given to me, so I know I'm either at this, one of the last two here that I'm doing in this actual lesson. So I need a side that is either between my angles, or I need a side that is adjacent to my angles. And if I'm looking at my triangles, the way they have it set up here, I notice that the center is in both of my triangles. So I'm going to say that AC is going to be congruent to CA by the reflexive property. So that I will actually have, oops, can't see that. Let me get my yellow here. This would be an angle, and a side. So that here on my reasoning, I would say that this is angle, angle, side for my proof. Flow proofs can be nice because they'll show you exactly how things have to line up with each other if you already know the pattern that it's supposed to give you. So here's your independent practice problems. I want you to work those. This flow proof down here at the bottom is a pretty simple one. They give you two of the parts. You have to come up with a third one to give you your end result. So it's pretty straightforward with the picture. You should be able to do all of those all on your own, but we'll check it in class.